There we go. Right, here we have my current plan for custom AEG gearboxes. So you can see I use a ICS split gearbox upper. The idea being that with the fixed position of this gear here, this selector gear, I can rotate all the other components of the gearbox around each other by clicking on the gears, and they will eventually have their own custom cutout meshes, so that when it goes to be cut away from the original model, you'll get the shape it needs to be rather than just the shape of the gears. But from this, I can then orient the gearbox in any kind of position I want to try and get it to fit inside the gun. So just undo that lot. So here we have the Titanfall car that I'm planning to work on. I have a very nice external mesh that I purchased off Etsy for the grand total of $9, which I think is a bloody bargain for this. But anyways, we've got the important bits back here are the pistol grip, the rear, and the middle, which I've split into their two halves here. So the issue, of course, is with this thin constriction here and the odd shapes of this, I can't necessarily fit a standard version 2 gearbox in here. So what I can do is go into top-down view, move in my parts into any position I want. So I can go there, there. When I've got this barrel sorted out with the positioning, because you can see it's quite low, I will be reworking it. But you can see I've also got the mag well to deal with, things like that. So with the mag well there, I want to move this a bit back. Maybe going for something a bit like that. You can see now, gears don't directly fit in that position. So if I select the lower bearing of that one, I can rotate it around until that fits like that. In fact, I'm going to go a bit further because I want to squish the positioning up, but also I've got to remember I can't interact with that pin there. Where's the other bearing? There's the other bearing. I can then rotate that around there, bring that down, and then rotate the motor about it to bring it parallel. I'm just going to rotate that around a bit more, like that. As you can see, I'll have one of the bearings particularly close to the surface there, and the motor will be fatter than the grip. I can rotate, if I just go into local, I can rotate that about there, and see it still won't quite fit, and that'll be probably one of the parts where I will modify the mesh rather than compromise the integrity of the gearbox. But with a bit of work, you could just about see how I can fit it into that area there. So now if I move this entire assembly forwards, you can see how it starts to fit in. What I'll probably end up doing is moving this mesh further down. But as you can see there, even with that, you can see I start having issues of bits sticking through. So you can play around with it, adjust the gear positions how you need to and how you want. And for this one, I might even say move the gearbox up a bit. Select the bottom of here, rotate it around the selector there. So just get into position I can see. There we go. Find the bottom bearing. There we go. Move that into position there. You've got to remember you've got to avoid all the bits of the gearbox and bits like that. And then rotate around like that. See, that's not going to quite work, but there is a possibility that it could. So if I go into that position there, you see how you can basically play around with the gearbox without actually having to produce a working model, which is part of the point of rapid prototyping, but also allows you to produce parts for guns in an orientation you wouldn't normally. Now that, whilst it looks bloody ridiculous, could theoretically work. If I didn't want to modify the mesh to make the pistol grip bigger, I'd have to look at moving this entire assembly back a bit. I've got a bit of space in the stock here, as you can see, because that base plate is there, but I could adjust the stock rather than adjusting a more significant part of it. I can move that around how I need to, and then say have a cutaway in the magazine that slots up to there. You can make it any orientation or combination of orientations you want, and then once that is complete, I can then extract this. I will then have a set of meshes around each object that will allow you to kind of cut away. So each gear would have their own volume that they would need to occupy as a cutaway. The motor component would have the motor ring that the hole's got to punch through, the base plate and the mounting for that to keep that all taut, and the ICS gearbox would have all the relevant spaces cut around that. And you might even be able to swap out for a long shafted motor or any kind of combination of the whatever you want. And then what you would do then is you'd select the base mesh, and I'd have it so that you'd import, or you'd open the blend file with the entire mesh already set up. You'd select the base mesh, apply the series of Boolean modifiers that would link all these different parts together, and that'll give you a single volume that you're able to cut away from any mesh you like. So you then take this volume, which is all the parts of this all together in that current orientation, move it over, and then Boolean it away from every part you have. And then that would allow you to very quickly and very easily remove the gears from the part and make it a functional airsoft gun. And then, so what you do is you just take all the parts you've got, slide it back over, still on local, global, slide it back over, Boolean it all apart to get a single solid cutaway mesh. So, and then you just print each individual component as it is, and you end up with a fully working 3D printed gearbox without having to spend hours calibrating it, fiddling it, seeing if this will get in the way of that bit or whatnot like that, and without having to use a single custom built cutaway each time. It will work for any gun I want to make. So I want to make a DMR later, I want to make any gun I can 3D model, or even if I want to, if I have a 3D model of a gun and I want to say, I wonder if I can fit a gearbox in there, rather than having to measure up an existing gearbox, which may not be ideal in any case, I can play around with it, fiddle, change the positions and see what fits without actually having to break the gun down or having to split it into all the little bits. It makes it a very rapid way of getting a one-off or a custom made gun very easily. Of course, you can also spot issues, like for example here, you can see the top of my gearbox there is slightly too fat for my gun. So what I'd have to do is drop that down. Things like that. And then you can kind of balance all the other issues, and basically allows you to troubleshoot all your meshes before having to print them and realize, oh shit, it doesn't fit. But anyways, that's the current plan, and this is the first time I put it in here, so I can see that there's a long way from the Titanfall card's a long way from being the ideal gun to have to work with, but I'm certain I can get it to fit, and especially when I can play around with it, as this system should now allow me. Anyways, I look forward to being able to post any more developments I get with this, and hopefully we'll have a fully working 3D printed airsoft gun for this in no time at all.